Good morning, everyone, or at least it is for me. Today we're going to go into matrices a little bit more. I will tell you that if you've taken secondary one honors, many of this you've gone through. So hopefully when you go through these notes, you're like, oh yeah, I remember that. If you don't, of course, be careful. And if you haven't done secondary one honors, you probably haven't done this. You might have done a little bit in secondary 3, but be careful, especially on multiplication. That's really where you want to make sure you're understanding what's going on, okay? So recall that a matrix is a rectangular array of real numbers, such like the following, okay? The size, sometimes called the dimensions, we'll really call it the dimensions of the matrix shown above, is a 2 by 3 because it has 2 rows and 3 columns. So what I want you to keep in mind is when we talk about dimensions, it's always rows by columns, okay? Now, the individual numbers are called entries. So if I said row 1, column 1, that would be entry 3. If I said row 2, column 3, that would be 10, okay? Two matrices are said to be equal if they are the same size and their corresponding entries are equal, okay? So they're equal if I had another 2 by 3 and all the entries were the same. And that kind of makes sense, common sense, right? All right, let's talk about our operations when it comes to matrices. So matrices addition. Given two matrices of the same size, so same dimensions, the matrix obtained by adding the corresponding entries of the two is called the sum of the two matrices. So we're going to find the sum of matrices A and B. The first thing you want to do when you find the sum, guys, is they have to be the same dimension. So the first thing you want to check, do they have the same dimension? This, of course, is a 3 by 2. And this one is also a 3 by 2. And because they are the same, that means we can add them. When we add them, we get, or what I should say, is that we add the entries in the same position to each other. This is also why you cannot add matrices with two different dimensions, because the entries won't line up and you wouldn't be able to add them. So 2 plus -1 is 1. 3 plus 4 is 7. 4 plus -5 is -1. -1 plus -3 is -4. 0 plus 8 is 8. And -7 plus 1 is -6. Hopefully you see that if people make mistakes on adding, it's because of their integers and those entries, not really anything else. So when it comes to addition, we have some properties that we can look at. First of all, matrices with addition are commutative. That means A plus B is the same as B plus A. It doesn't matter which order we do it in. The associative property. Again, if we have 3 matrices that we're adding together, and of course they have to be in the same dimensions, we can add whatever 2 we want first, then add the third, and it's the same thing. The identity property. In other words, if you have a matrix and you add the 0 matrix, which is just zeros as all the entries, you get itself. Inverse property means that every matrix A has a unique added inverse, denoted as -A, such that A plus -A equals 0. Okay, so we're going to talk about this -A in a minute, because of course this is, you can also say this as -1 times the matrix of A. Okay, so we'll talk about that in a minute. Matrix subtraction, okay? So there's 2 ways you can look at this. You could say A minus B, or you can say A plus -B. So it's going to be up to you on how you decide to do that. I will do it both ways so you can make a good judgment for yourself of what to do. So the first thing I'm going to do is do my subtraction. Okay, so first of all, I have to make sure they're the same dimensions. This is a 2 by 2, and this is a 2 by 2. So I know I can subtract them. Then I'm going to subtract each entry. -2 minus 8 is -10. 3 minus -1 is 4. 0 minus 5 is -5. And 1 minus 4 is -3. Again, if you are good with your subtraction and everything, that's going to work wonderful. But if you know that you messed up on your subtraction a lot, it's going to be easier to do this, which is a plus -b. All right, so what is that exactly? So I'm going to show you in the matrices. So my A stays the same. And what I'm going to do is I'm going to add a -b. -b means I multiply each entry by -1. So this would be -8, +1, -5, and -4. And now we can just think of addition. There's our -10, there's our 4, there's our -5, and there's our -3. So that's going to be up to you, okay? Just don't go back and forth between the two ideas, because that's where you make, your small mistakes. Which, when I multiplied matrix B by -1, that's actually what we call scalar multiplication. So in other words, we have a constant out front, and we're going to multiply all the entries inside matrix by that constant, okay? Hence why I said -1, and how I said we'd come back to that. Okay, so when I do these steps, I'm going to do the scalar multiplication first and then do subtraction. Or I'm going to do the scalar multiplication with 2 and -3 and then add them. So again, that is going to be up to you on what you want to do. So I'm actually, because I do like addition better, I'm going to multiply B by -3 and add the two together so I don't forget. So let's just make sure we can do this. First of all, this is a 2 by 3, and this is a 2 by 3. So we are good to go. All right, 2A. So I'm going to multiply all the entries in A by 2. -2, 0, 6, 4, -2, and 8. Now remember, because I'm multiplying B by -3, I'm going to add these two. So -6, -3, 9, -12, 0, -3. All right, hopefully I didn't make a mistake. -3s, right? All right, and now I can add these two together. -2 and -6 is -8. 0 and -3 is -3. 6 and 9 is 15. 4 and -12 is -8. -2 and 0 is -2. 8 and -3 is +5. Hopefully you guys see that that addition went a lot faster than if I multiplied 3 and did minus. Because with subtraction, we really have to be careful with those negatives, right? All right. We good? All right, here's a big one. Matrix multiplication. Okay. When we multiply, I will tell you that the dimensions do not have to be the same. Actually, most of the time they won't. But because what we have to do is multiply the rows by the columns, our dimensions have to be in a certain form. what happens, and I'm going to actually mark this out, okay, is if we have a matrix M by N, the only way to multiply, and I'm going to say, let's do different letters, R and S. What happens is M and S must be the same. So M must equal S. Once we know that happens, and we know that our new matrix will be of the dimensions. Oh, please don't run out. Yep, it's going to run out. The new matrix will be of the dimensions N times R. Let's see if I can. I hate when this happens, guys. M. Oh, not M. N. N by R. Okay? And I'm going to show you down below first that we can multiply these two, and then what we're going to do is I will show you how you are going to multiply. Okay, so right here we have a 2 by 2, and this is a 2 by 3. Oh wait, it's the other way around. Ha, messed up, guys. Sorry. That is my fault. What is with me? It's the morning. The N and the R have to be the same. N has to equal R. For those of you who took secondary 1H, did you recognize that? That I made that mistake? There we go. And our new matrix will be the outer two. So the inner two have to be the same. I don't know what I was thinking. All right, so what I actually want to do right now is I'm going to pause this video because I like using colors when I show the first time matrices, okay? So, of course, it won't be paused to you, but it will for me. All right, I'm back. So, first of all, I want to point out here that our N and R, or they use P, right? They are the same, so that's great. And then what we need is our new matrix will be a 2 by 3. Okay, so what I like doing, and I'm going to make it super big right now just so you can see all the math. Okay, so again, I'm making it super big just to see the math. Are you always going to have to make it this super big? No. So what I did, well, I was paused the video. You didn't see that. I have 6 colors because a 2 by 3 means I'm going to have 2 rows with 3 columns, so 6 elements. What I am going to do is I'm going to color code this so you can see my movements. Will you always have to do this? No. Hopefully, I'm using different colors in a way that many of you can see the difference. What color am I missing now? I'm missing purple. There we go. Okay, so why is it that our rows in our first matrix has to be the same as our columns in the second? It is because we are going to use the row of the first times the column of the second. Okay, so I'm going to write this down as a note, but you will write all the math down. So this element, as you can see, is in row 1, column 1, right? So what that tells me is I'm going to take row 1 of A, column 1 of B. Now I'm going to use my colors so I remember. So I'm going to do row 1, column 1. So what does that tell me to do? Well, that tells me to take the element in my row, so 1 times 3 plus 2 times -1. So see, if I were to line up my row and shift it to my column, I would be multiplying 1 and 3, 2 and -1, and then I'm adding them together. So when I do this, I get 3 plus -2, which is 1. Okay, and then I'm going to do that again. This one, I'll do the green one down here. This is row 2, column 1. Row 2, column 1. Which means I'm going to take row 2 of the first one, column 1 of the second. Now, if I could find a pencil that actually does me well, I can write this out. So, -2 times 3 plus 3. I guess I want it to be consistent. 3 times -1. All right, let's do that math. Of course, you guys can always use your calculator if you need so. That is -6 plus -3 is -9. All right. It'd be nice if I could get a pencil that stays with me, but I guess I'll use this pen. This is row 1, column 2. So we're using that kind of orangey red. So row 1, column 2. So I'm multiplying 1 times 0 plus 2 times 2. That's 0. 0 plus 4 is 4. Okay. Next, I'll do this one down here. Row 2, column 2. That is the dark blue. So row 2, column 2. So that is -2 times 0 plus 3 times 2. All right. What does that give us? 0 plus 6 is 6. See how this can take a while? But what I would do is take your time to get in a pattern so that way you don't make your mistakes later, okay? So row 1, this is my brown. Row 1, column 3. So we get 1 times 5 plus 2 times 4. So 5 plus 8. 5 plus 8 is 13. And last one, guys. Row 2, column 3. In purple. Row 2, column 3. So this is -2 times 5 plus 3 times 4. Okay, so that's -10 and 7 is -3. Okay, do you guys see a pattern going on? If we go down, you see my parentheses, I have all the same numbers. If we go across, I have all the same numbers in front. Okay, that will help you out. Now, what of course we're looking for is the 1, 4, 13, -9, 6, and -3. I wrote this stuff down because it's my work and I can double check my process. That is multiplication. All right, so addition and multiplication when it comes to matrices is not the same properties, unlike our normal numbers in, you know, adding and subtracting and multiplying, right? So our properties of multiplication. So we have commutative does not work. So as you can see, we're missing commutative. So A times B is not the same as B times A. And we'll go over that. Actually, why don't I go over that now? I can go back to this example, okay, to show you. We just multiplied A times B. But if you look, and let's say I did B times A, well, B is a 2 by 3, and A is a 2 by 2. And as you can see right here, 3 does not equal 2, so you cannot do it, okay? So it does not exist, something like that, or no solution. No solution would be better. Okay, so commutative property does not work, but associative does. So A times B and then times C is the same thing as B times C and then A. Now what I want to show you though with the associative property is the order is still the same, okay? All right, scalar multiplication. Same thing here. We can either say A times B and then multiply it by our constant, our scalar out front, or we can do one of two things. We can take our scalar, multiply it by A, or multiply it by B, and then multiply the same matrix. Now again, order is still the same, okay? Identity. So we're gonna go over identity in a minute. That's almost like multiplying by 1, okay? As you can see, we can do the identity times the matrix A or matrix A times identity and still get matrix A. Sorry. The distributed property. So we have matrix A, matrix B, and matrix C. So whether we're adding or subtracting A and C, we can still multiply each. We can multiply A times B and then A times C, and then add or subtract them together, or we can do it the other way. Sorry. I need to learn to stop that quicker. All right, so what does the identity matrix look like? Again, I said it's like multiplying by 1, right? But the difference between the zero matrix is all zeros for the elements. But for the identity matrix, which by the way has to be a 1 by 1, 2 by 2, 3 by 3, so our M and M have to be the same dimension. It has to be like a square. What happens is our ones are in the diagonal. So identity matrix means 1 is in the diagonal and the rest of elements are 0, okay? All right, lots of times what professors will do when it comes to matrices to make it easier on themselves is they'll have just a group of matrices up here, and then we'll have a bunch of operations, and that's what we're gonna do right now, okay? So we have A plus D. What I recommend doing when you have something like this is make sure you rewrite the matrix so you know you're doing it correctly. So 1, 2, 0, and -3 is matrix A, and we're gonna add D, which is 0, -1, -2, and 3. All right, with addition, our dimensions have to be the same, so let's check our dimensions. This is the 2 by 2, 2 by 2. Can we do it? Yes, we can. So 1 plus 0 is 1, 2 plus -1 is 1, 0 plus -2 is -2, and -3 plus 3 is 0, and we are done. All right, A again. So 1, 2, 0, -3. And then we have plus 1, -1, 2, 0, 2, and 1. Let's look at our dimensions. So this is a 2 by 2, and this is a 2 by 3. Well, if this was multiplication, we could do it. But because it's addition and they have to be the same, we can't. So we're going to say no solution. Now, if by chance your question asks you to explain why, you can say, because in addition, our dimensions need to be the same, and they are not here. All right, B times C. So we've got 1. I'm hoping, guys, that this doesn't work because I don't have enough room to write all my work down. So there's B. And then we have C, so 0, 1, negative 2, 3, 1, and 0. This is a 2 by 3, and this is a 3 by 2. So we can do it. So what I am going to do is on another sheet of paper, I'm going to do my work just to make sure that I do all of this correctly. Okay. So the good thing is, knowing that these two are equal, I know my new matrix is a 2 by 2. I'm going to make it big enough so that way I give myself enough room. Okay, so that's how I'm making it. All right, so row 1, column 1, which means I'm going 1 times 0 plus negative 1 times negative 2 plus 2 times 1. Okay, again, 1 and 0, negative 1 and 2, 2 and 1. 0, 2, and 2. So right here, the element is 4. Sorry, you didn't get to see my work there. I'm going to do this one next, which is row 1, column 2. So row 1, column 2, so that's 1 times 1 plus negative 1 times 3 plus 2 times 0. Right? 1, 3, yep. Okay. Let me look at that. So that's 1, negative 3, 0. So that would give me what? Negative 2. All right, next one. We have down here, we have row 2, column 1. So 0 times 0 plus 2 times negative 2 plus 1 times 0. 1 times 1, sorry. And I'll show you that in a minute. 0 and 0, 2 and negative 2, 1 and 1. So 0, negative 4, and 1, which would be negative 3. All right, last one, row 2, column 2. So 0 times 1 plus 2 times 3 plus 1 times 0. Right? 1, that one, that one. Good. So 0, 6, and 0, so get 6. So I want to make sure I label my correct answer here. So I get 4, negative 2, negative 3, and 6. Woo! I know I did that kind of fast. If you need to slow down and use colors like I did that first time, go for it. Okay. Oh, I'm going to need my matrices on the side, right? So C is 0, 1, negative 2, 3, 1, and 0. And then we're going to multiply by B. So 1, negative 1, 2, 0, 2, and 1. Let's look at our dimensions. This is a 3 by 2. This is a 2 by 3, so it does work. Okay, so 2 and 2. So our ending matrix is going to be a 3 by 3. if you want right now, what I would like you to do is pause the video, do it yourself, and then turn it back on, and I will go through how to make this matrix, okay? If you're here with me now, I will go through the steps. This is a 3 by 3. Okay, I'm going to do row 1, column 1, so it's 0 times 1 plus 1 times 0, which is great because that means it's 0. All right, next one right there. We get 0 times negative 1 plus 1 times 2. If you guys don't notice, I'm doing row 1, column 2. That would be 0 and 2, which is 2. And I've got this third one here, which is 0 times 2 plus 1 times 1. That's 0 and 1, which is 1. Okay, next one. This is row 2, column 1, so this would be negative 2 times 1 plus 3 times 0, just negative 2. I get negative 2 times negative 1 plus 3 times 2. That's what? 2 plus 6 is 8. I get negative 2 times 2 plus 3 times 1. Negative 4 and 3 is negative 1. Okay, so row 2, column 3. Last one. Let's see if you got this right. So this is 1 times 1 plus 0 times 0, which of course is 1. Be careful on your multiplication and addition. Okay, row 3, column 2. So row 3, column 2. 1 times negative 1 plus 0 times 2. Negative 1 and 0 is negative 1. And last one is 1 times 2 plus 0 times 1, which is 2. How'd we do? Did I make any mistakes? Hope not. Okay. Continue. Okay, B times D. Okay, B. Well, let's see if we can do it. That way we save some time right now. B is a 2 by 3. And D is a 2 by 2. So right away, can we do it? These are not the same, so you can't do it. No solution. Okay, now we have a 2 by 2, which is D, and a 2 by 3. Can we do it? Yes, we can. Okay, so 0, negative 1, negative 2, 3, times B, which is 1, negative 1, 2, 0, 2, and 1. Okay, that means this is going to be a 2 by 3. Okay, I'm going to do this on another sheet of paper so I can see my work. You guys can see. So row 1, column 1. So 0 times 1 plus negative 1 times 0, which of course is 0. Okay, row 1, column 2. So 0 times negative 1 plus negative 1 times 2, which is negative 2. It's nice when they use 1s and 2s because it's really easy, right? 0 times 2 plus -1 times 1. That's -1. Okay, row 2, column 1, -2 times 1 plus 3 times 0. -2. -2 times -1 plus 3 times 2. That's 2 plus 6 is 8. And then our last one, -2 times 2 plus 3 times 1. -4 and 3 is -1. Okay, I know that I did that multiplication pretty quickly. Again, I've been doing it for years, right? So what I want you to make sure you are doing is that if you need to use colors, if you need to slow down, maybe even go back to the last couple of examples I just did, do them yourself. See if you can come out with that pattern. See if you have the right answers, okay? Now, our last one, we're using the identity here. Now, it says identity, and then it has a subset 2. That means that's the 2 by 2 matrix, and that diagonal is 1, and the rest is 0. Okay, so I'm actually going to set this up and write my matrix C in there. So I have C squared, which is 0, 1, -2, 3, 1, and 0, and I'm squaring, so I'm multiplying it by itself. Minus 5 times C. Oh, I'm using the C from before, but this is C. Did you guys see my mistake there? And of course I'm in pen, so that's not nice. I was wondering that because this would have been no solution right here. Oh, too many C's. Sorry, guys. So we have a 1, -2, 3, and 4, and we're multiplying it by itself. Now, what I'm going to do with the scalar, I'm just going to write it in for you guys, and then we're going to do the math after, okay? Plus, now 10, the identity matrix, right? So remember, it's a 2 by 2 with the diagonals being 1 and the rest being 0, okay? Now, what we're going to want to do is do this 2 by 2 on another sheet of paper if you need to show that work. I would multiply the -5 out so I could add instead of subtract, and then multiply that 10 out, okay? So, first thing we're going to do is this 2 by 2. Of course, a 2 by 2 will give us a 2 by 2. So, let's see, I've got 1 times 1 plus -2 times 3. What does that equal? That is -6, and 1 is -5. The next one here, I've got 1 times -2 plus -2 times 4. That's what? -8, and -2 is -10. I shouldn't get that up there. Sorry, guys. Okay, let's do row 2. We get 3 times 1 plus 4 times 3. That's 12, and 3 is 15. And then the other one, we get 3 times -2 plus 4 times 4. What is that? 16 and -6, so +10. All right, let's see what else we can do now. All right, let's do our scalar multiplication. I'm going to add though. Okay, so I'm going to multiply by negative 5 here. So negative 5, positive 10, negative 15, and negative 20. So I multiplied each element by negative 5, so it's easier to put together. And now I'm going to multiply these by 10. So this is 10, 0, 0, 10. Now the great thing about all multiplication or all addition now is that I don't have to add these two and then add these. I could pretty much add. Just make sure that you have the same element. And this is my answer down here. Sorry, I'm squeezing it in. Negative 5 plus negative 5 is negative 10. Negative 10 plus 10 is 0. Negative 10 plus 10 is 0. Plus 0 is 0. 15 plus negative 15 is 0. 0 plus 0 is 0. 10 plus negative 20 is negative 10. Negative 10 plus 10 is 0. And look what we got, guys. We've got a 2 by 2 0 matrix. Yay, we're all done. Be careful on your adding and subtracting with those negatives. Watch how you multiply. Let's learn where our mistakes are coming from so we take our time when it comes to those questions. Have a great day, guys.